The history and evolution of the use of geothermal energy. Long before electricity, before the industrial age, and even before recorded history, humanity was drawn to the Earth's natural warmth. The steam rising from fissures, the bubbling pools of hot water. These were not just natural phenomena, but direct manifestations of the powerful heat beneath our feet. Today, we call it geothermal energy, and its story is as old as civilization itself, evolving from a mystical wonder to a cornerstone of modern sustainable power. The earliest interactions with geothermal heat were purely direct. Archaeological evidence suggests that even Stone Age humans in parts of Europe utilized hot springs, perhaps as early as 20,000 years ago. The readily available hot water and steam were used for comfort, cooking, and even for crafting tools from naturally heated obsidian or pumice stone. The Romans, famously, were masters of thermal engineering. Their elaborate bathhouses, like baths of Caracalla, were not just places of hygiene, but social centers, heated by complex systems that channeled natural hot spring water. Across the globe, from the indigenous peoples of North America to the Maoris of New Zealand, hot springs were revered for their therapeutic properties, used for healing, cooking, and even as strategic military locations for their natural warmth in harsh climates. Iceland, too, has a long history with Snorri Sturluson's baths from the 12th century, being one of the earliest documented use of geothermal for space heating. This era established the fundamental concept: Earth's heat could be directly utilized for human benefit. While direct use continued, the 18th century marked a significant turning point: the dawn of industrial exploitation. The true genesis of geothermal as an industrial resource began in Laudorello, Tuscany, Italy. In 1777, Francesco Giacomo Laudorella, a Frenchman, pioneered the extraction of boric acid from the natural steam vents, or soffini, in the region. This was a challenging process, as the highly corrosive steam contained impurities. Lardorel developed innovative techniques, including the use of lead vats and later direct steam heating to concentrate the boric acid. This wasn't about electricity yet, but it was the first large-scale, sustained industrial application of geothermal resources, demonstrating that Earth's heat could power chemical processes and create valuable products. The Lardorello name became synonymous with this pioneering spirit, laying the groundwork for future energy applications. The ultimate leap, converting geothermal heat into electricity, occurred in the early 20th century, again in Laudorello. Building on the industrial legacy, Prince Piero Giovanni Conti took the decisive step. In 1904, he successfully powered four light bulbs using a generator driven by steam from the geothermal vents. This seemingly small experiment was monumental. Just 7 years later, in 1911, the world's first commercial geothermal power plant was commissioned at Lardorello. It wasn't a smooth path. The highly corrosive nature of geothermal fluids presented immense engineering challenges. However, Italian engineers tirelessly innovated, developing new materials and techniques to handle the harsh conditions. This breakthrough proved that Earth's internal heat could be a viable source of clean, dispatchable electricity. The success at Laudorello inspired others. New Zealand followed in the 1950s with the Waikare Power Station, and the United States joined in the 1960s with the geysers in California, which would eventually become the largest geothermal complex in the world. The era of geothermal electricity had truly begun. The latter half of the 20th century saw significant diversification and technological refinement in geothermal use. Early power plants primarily used dry steam or flash steam technology directly utilizing high temperature steam or flashing hot water to steam. A major innovation came with the development of binary cycle power plants in the 1980s. This technology opened up the use of lower temperature geothermal resources by using the geothermal fluid to heat a secondary working fluid like isopentane with a much lower boiling point. This allowed geothermal power to be economically generated in more locations, significantly expanding its global potential. Simultaneously, the widespread adoption of geothermal heat pumps, GHPs, for residential and commercial heating and cooling revolutionized direct use. GHPs leverage the stable temperatures of the shallow earth to provide highly efficient climate control, further demonstrating geothermal's versatility beyond electricity generation. And as we entered the 21st century, the focus shifted towards maximizing efficiency, minimizing environmental impact, and perhaps most importantly, unlocking the vast untapped potential of geothermal energy. From the first primitive uses in ancient baths to powering modern cities, geothermal energy has journeyed through millennia, continually adapting and innovating. It stands today as a proven, reliable, and increasingly accessible cornerstone of our sustainable energy future, poised to play an even greater role in global decarbonization. The history of geothermal energy is a testament to human ingenuity and our enduring connection to the earth. It's a story of learning how to harness one of our planet's most fundamental forces, its very heat, for comfort, industry, and now a truly sustainable future. Geothermal remains Earth's ancient yet ever evolving gift to humanity.